Hello and good day, students. This is the first recorded lecture on differential equations. Regarding every detail of this course, it is found on our syllabus that I have posted on eLearn. Today, I'm going to discuss on introductory concepts, principles, and terminologies na atong paggamiton as we learn differential equations. The very first question nga dapat atong i-answer is, why do we study differential equations? Simply saying, ang world around us could not be perfectly defined using algebraic equations, just like when we studied physics. If nakadumdum mo dito sa physics, we've defined gravity, velocity, acceleration, even electricity in terms of static or fixed algebraic equations. Consider projectile motion. Now, if you'd remember, na-define to with 4 algebraic equations. Variables na atong gina-consider are time, mass, initial velocity, angle, and some other parameters. So, if natay ato mga values, i-plug nato sa equation, then perfectly ma-predict nato kung asa mo fall ang atong projectile or atong object. But for a realistic na projectile, let's say a rocket, na all those variables are changing at all times, no? Say for example, ang mass, every time the rocket goes upward, i-change ang mass because kaka-burn ang fuel. Not only that, but almost everything is changing. Atmospheric pressure, even ang position sa Earth, no, kung asa siya dapat mo land. That's why algebraic equations alone could not perfectly define the real world around us. Hence, the need to study differential equations. We need then differential equations as our tools to understand nature and also to design and create systems as future engineers, also to solve engineering problems. So just to be clear, solving differential equations are not the end point of this subject. No? So if we look at the chart, we start with our physical system. It may be, again, the nature around us, or it might be a system nga atong gusto i-design, and then we extract the variables and create our mathematical model. That mathematical model is in the form of a differential equation. With that, we have to solve tong differential equations to have our mathematical solution and interpret that mathematical solution back to our physical system. Again, it may be something ang gusto nato i-design, like an electrical system or chemical na system or mechanical na machine. No, all those could be defined by differential equations. One advantage to working with mathematical models is that it's not necessary for us to build the system for us to test it or see if it works. With mathematical models, karon pa lang mabal-an nato kung mag-work ba siya or dili, because building a system to test it would be costly. Just like to imagine magbuhat daan og building only to test it and did they mag-work, di ba? Imagine how much money and effort it would take to do that, no? So with mathematical models, mainly differential equations, using computers, pwede nato mabalaan kung mag-work ba ang atong design nga system. So here are some examples of differential equations. There are differential equations that define natural phenomena like gravity, water flow, and even if you look the Lotka-Volterra predator-prey model, those are naturally occurring phenomena that could be described using differential equations. There are also differential equations that describe engineered systems like electrical circuits, mechanical machines, and even our vibrating mass on a spring. Okay? Even sa economics o sa study of financial systems, gagamit gyapon sila og differential equations. So for the context of our course, we could start by looking at already discovered differential equations or already formulated and then solve it. As we progress, we could encounter word problems where kita mismo ang define no, sa differential equation. So I hope this gives us a deep motivation kung anong important gyud nga mag-study ta og differential equations. Dili tungod kay required siya, but also it is a fun and rewarding way to understand the world around us. With all the mention of differential equations, actually wala pa man nato gi-define, di ba, unsa ang differential equation. So ang next slide ato nang tan-awon, what are differential equations? Differential equations then, or DEs or DFQs, are equations that have differentials. Okay, medyo simplistic sa pagka-define, pero mo gid na ang simple nga definition sa differential equation. Siguro it begs the question, what are differentials? To refresh your memory from calculus, differentials are notations that describe derivatives, di ba? Or rate of changes. Another way to define differential equations are, these are equations such that its solution is a function that satisfies the said equation. Kung atong i-compare before sa algebra, we are given an algebraic equation. Kung atong i-solve ang algebra, ang final outcome is a value, di ba? A numerical value. But these are differential equations. We are given a DE, or a differential equation, and ang solution sa differential equation is not a value, but a function. Okay? In the same way sa algebra, para makabalo ta kung correct atong answer, i-substitute na to ang atong final answer sa given algebraic equation. The same gyapon dire. For us to verify if our final answer is correct, we will plug our final function to our given differential equation. If you'd look to the right, here are some examples of differential equations. But differential equations come in different shape and form, and pwede na to siya i-organize or categorize into different types, no? First off, differential equations can be classified according to its type. It could be an ordinary differential equation or partial differential equation. Basta kay dili partial, ordinary na siya. Sa atong course or kaninga subject, we'll only be dealing with ordinary differential equations. We'll reserve partial differential equations sa higher mathematics. Sa pagtanaw pa lang, dali naman ma-differentiate kung sa ang ODE sa PDE. Basta ganit na ay stylized D that denotes partial differentiation, partial derivative na siya. Okay? So the first equations are ODEs. The last one is a PDE. Differential equations can also be classified according to its order. Now, what is an order? The order of a differential equation is the highest derivative that occurs in the equation. So, atong tanawon ning upat ka equation. The first one is a first order kay y prime naman naa, no? That's a first order DE. The second equation is a second order differential equation kay na may y double prime, no? Or second derivative. Ang third equation, y prime times y triple prime. Oh, okay. So, that's a third order differential equation. Ang atong PDE is a second order PDE, or second order partial differential equation. For the first few weeks, mag-focus ta sa first order differential equations. But in hindsight, no, actually masayon i-solve ang mga higher order kaysa first order differential equations. DEs can also be classified according to its degree. So the degree of a DE is the power of the highest derivative of the equation. Okay? So, if kadumdum ta sa order, kung unsa to nga derivative ang nga-define sa iyong order, tanaw na to kung unsa iyahang power. So, sa to say, kaning mga examples nga atong gisat diri, these are all first degree differential equations. Kay, tanawa ang third equation. Y prime, y triple prime minus 3 halves, y prime squared is equal to 0. So, this is still a first degree, third order. Kaya ang degree sa ang degree sa third derivative ng y triple prime is, yung power is 1 naman na siya. So, that's a first degree, third order differential equation. Well, anyway, don't worry kay kaninga concept is medyo trivial man siya. No? Dili kay siya nakadako nga matter when it comes to solving differential equations. Differential equations can also be stated either explicitly or implicitly. So, kanang naka-highlight og blue, munang general form sa explicit DE, and kanang ikaduha is an implicit form. So, natay duha ka equivalent differential equations, para na silang duha, lahi lang og form. The first one is in explicit form, ang ikaduha, implicit form. So, how do we know kung explicit siya or implicit? Basta kay, if ang differential nasa left side sa equation, just like the first equation, y prime is equal to a function, that's explicit. Basta ang isa ka differential is nalagid sa one side sa equation, explicit na siya. Pero, just like sa second equation, that's implicitly stated because ang y prime is na ay coefficient. Okay? Basta if nagsagol-sagol gani ang kuan, ang mga differentials, most probably implicit na siya. Pero if nasa isa ka side lang sa equation, most probably sa left side, ang differential, explicit na siya. Okay? So last concept for this lecture is initial value problems. So when solving differential equations, we usually find the general solution. Okay? So kung mag-solve tag differential equation, usually ang general solution na siya ang atong ginapangita. Now to find the unique particular solution, the general function will be subjected to initial conditions. Na if kadumdum mo sa calculus sa una, kada bitong limits para ma-replace ang c, okay, or definite integral or definite integration. So the same na siya ani. Para ang differential equation ma-solve na to particularly, we need to subject our solution to initial conditions. Now don't worry, ang initial conditions given gina siya always. So simply stating, ang initial condition is what is y when x is 0. So nato example dili y prime or dy over dx is equal to 3y. Its initial condition when x is 0 is 5.7. So muna siya ang atong initial condition. Okay? So ako lang nang gi-introduce karon kay para aware ta. And there is such thing as a initial value problem. So if wala siya initial condition, dili na siya initial value problem. Usually maka-encounter tag initial value problem kung word problem ang atong gina-solve. Okay? So I believe these are the most important concepts and terminologies for us to start solving differential equations. So I will be posting an activity sa e-learn in the form of exercises para ma-practice ninyo inyong na-learn sa kaninga lecture.